All right, so can you guys see my screen? Okay. All right, so let us now continue our discussion. So one thing that I forgot to mention a while ago on why we are talking about number system. What is number system? Okay, that's because that's what or how our computer reads the data. So let me just open another notepad. So as I'm typing right now, let's say I'm clicking A, B, C, D, E, F, G, and so on and so forth. Our computer doesn't read this one as letter A. Let's say I click A, and then it will be read as A, and then it will be displayed as A. No, it doesn't work like that in computer. So this A actually has its own representation wherein if you guys are going to go here at the last slide, okay, so we are using this ASCII code, okay. So for example, a small letter A, okay, this one is represented by 97, 61, 141, or even hashtag 97. So it has a lot of different representations. So it could be decimal, it could be hexadecimal, or it could be octal or HTML. So if it's in decimal, then the one that it's being read is 97. If it's hexadecimal, then the one that's being read is 61. If it's octal, then the one that's being read is 141. Okay, so it doesn't can be read as a letter A right away. Okay, so they have their own ASCII representation. Okay, so for capital letters, for small letters, for special characters, the one that we can type in our keyboard. Okay, and then for let's say call this one unprintable. Okay, these things are cannot be printed, or like the shortcuts that we can have on our keyboard also. Okay, and so on and so forth. Okay, so basically this letter A could be a number, okay, depending on the representation of that letter A. So we have a lot of variations for that. Okay, so I hope you guys got the idea, okay, on why we're talking about number systems right now. All right, so going back to our discussion. So again, just like what I mentioned a while ago, so if it's a whole number, then it starting from 0 and then it's increasing by 1. So 0, 1, and 2. Then if it's a fraction number, then starting from -1 and then decreasing by -1. So -1, -2, and so on and so forth. So yeah, well, for you to be able to understand this one a bit more, let's have an actual example. So we have this conversion exercises. So we have 6 numbers. So don't you guys worry. All of these items right here has their own solution. Okay, so you can find it right here. So solutions to A and B. So here is the letter A. So starting from binary. So we want to convert this one into a decimal. So having this one, just arrange this one from top to bottom. Okay, that's the first step that you can do when it comes to converting any base decimal. So just arrange that one from top to bottom. So starting from here, it's 1, second is 1, and then 0, and then 1, and then 0, and then 1. Okay, and then after that, starting from the last, okay, number or the lowest bit. So of course, since this one is whole number, this is start with 0 and then increment that one by 1. Okay, and then where this multiplier came from, this 2 right here. So this one came from the base. So that is why if you guys are going to take a look on this one, whatever is the base, okay, our initial base right here, that's our multiplier. Okay, so that is why in here our multiplier is 2 because that's the base of this number system. So everything is times 2, and then starting from 0, then it's incrementing by 1. So 0, 1, 2, 3, 4, 5. You can also start right here. However, you have to count the characters that you have in here. Let's say you have 6 characters, right? So just minus 1, okay, because we're going to start with 0. So starting from here, it's 5, 4, 3, 2, 1, and then 0. Okay. So do not put here 6, okay, because we started with a 0. So it's always less 1. Then after that, just do the math, just add everything. Okay, you can use your calculator. Then you'll get 53. Okay, and then of course, once you have already converted this base, this binary, into decimal, and do not forget to put the unit, see, in decimal, which is 10. Okay, so this is an indicator that you have already converted this binary into a decimal. So did you guys get that one so far? So are we clear, or any clarification on our letter A? So just give me a thumbs up once you have already got the logic, or once you have already understood the letter A. Okay, good. Seems that most of you uh, already got it. All right. So this is just for the whole number. But what about if we now have a fraction number or a decimal number? So it's basically the same idea. Just arrange everything from top to bottom. However, in letter B, it's not arranged from top to bottom. It's actually a zigzag. So starting from here, it's 1, followed by another 1 is now at the right. So it's from left to right, left to right, left to right, and then going down. Okay, you might get confused on the arrangement, but yeah, that's the arrangement on this one. So 1 1 is this 1 1, and then 0 1 is this 0 1 right here, and then 1 1 is this, oops, 1 0 is this 1 0 right here, followed by the 1 right here, and then this one now is our fraction number. So that's the reason why we now have raised to negative 1, raised to negative 2, and then raised to negative 3. Okay, but for this part right here, so we are a whole number or an integer number. Okay, so again, starting from this decimal point right here, so it's incrementing by 1, so 0, 1, 2, 3, 4, 5, and then 6. Okay, and then starting from this point again, and then it's now on the fraction number, then start with negative 1, so just decrement by negative 1, so negative 1, negative 2, negative 3, and so on and so forth if you have more numbers on that fraction number. Okay, and then our multiplier is the base of this one, so our base is 2, so just multiply everything by 2, and then again just do the math using your calculator. So in here you can do it manually, of course, but in here, since we have a raised to negative 1, so this one now is 1 half, 1 fourth, 1 eighth, so it's now quite hard to analyze that one using our brain. Well, unless if you're a math genius, then no problem. Okay, so just add everything, and then you will get this one, 109.625. All right. So one thing that you guys need to see also, or check also, is just add everything, okay, for the whole number first, which is equal to 109, and then just add this one also separately, okay, and then you will get 0.625 or 625. So 1 half plus 1 8, okay, is equal to 625. Let me just check if you're going to 1 half plus 1 8. Yeah, it's 0.625. Hmm. I think you can, yeah. So you can do it in one shot, since they are in, you know, proper uh, value, wherein 1 half is 0.5, and then 1 8 is 0.125. Okay, and then it will give you a result of 0.625. Okay, so are we clear so far for the letter A and B? All right, so 3. Okay, so may I know your comment on this one, guys. Uh, is number system hard, or uh, it's still okay to you guys? So can you guys still follow up to this point, or you guys now are confused a little? Okay. So for Mr. Kiwas, maybe it's fine to him. But what about the others? Okay, yes sir, okay lang. Okay, so good to know that. Alright, so that's it for the first two example. Let's now move on to the letter C and D. So just like what I mentioned a while ago, so you can convert any base to a decimal. So we can also convert this octal into a decimal. Okay, so the same concept, just arrange this one from top to bottom. So 4, 5, 3, 6, and then your multiplier is 8. And then starting from here, of course, start with 0, and then it's incrementing by 1. Then just add everything, and then you will get this one. So just recheck this one later on if we have the correct answer using your calculator. But for now, just see the logic, okay, on how did we get this 2398, okay? So are you guys able to follow on how did we get letter C? Is everything normal so far to you guys? Okay. So if you want, you can verify it now so that just in case that, this answer was actually incorrect, then we can change it right away. Okay. How about letter D? Okay. So the same concept, it's just a different number. Okay. So 1, 2, 7, and then 4. And then starting from 7, it's 0, 1, and then 2. Okay. And then for 4, of course, it's just negative 1, a raised negative 1. And then our multiplier is 8 because that's the base of this number system. And then just add everything, and then you will get 87.5. Okay. So please verify. Is this correct? Okay, so coming from Mary Ein, so she said that it's correct. What about the others? Were you guys able to verify whether the answer is correct or no? Or can you guys follow the process on how did we get those results? Okay. All right, so great. I hope the others who are not responding were also able to get this one. Okay, last one is letter E and F. So a while ago we have binary to decimal, and then we have octal to binary. Now we have a hexadecimal to a decimal. Okay, so in here we have V65F. Okay, but remember that in hexadecimal, there are some that's being represented by letter, certain letter, and then they have their own values in decimal. So B is actually 11, and then F is 15. Okay, so starting from 10, it's already A. So just increment it. Okay, 10, 11 up to 15. And then the same with letters. So it's ascending. So A, B, C, D, E, F. Okay, that's basically the pattern that you can remember or you can memorize when it comes to hexadecimal. So B is 11. 6 is still 6. 5 is still 5. And then F is 15. And then our multiplier is 16 since that's the base of our number system right here. And then starting from F, so it's raised to 0 up to the last character, which is 3. Okay, and then just add everything, and then you will get 46,687 base 10. So please verify, check whether this one is correct or no. So is it correct? Okay, great. So I hope the others are also checking this one or verifying this one. All right, so next one now is NBs. So remember that we have decimal. Actually, we have binary, which is 0 and 1 only. Okay, and then decimal is 0, and then that's the normal way to count numbers in a computer. But of course, we're going to start with 0. Hexadecimal has a combination of letters, and then octal doesn't have 8 and 9. Okay, and what if we have a base of 3? Okay, so binary has a base of 2, decimal has a base of 10. Nagulo na naman. Anyway, so let me just remove this one. Binary is 2, base 2. Octal is equal to base 8. Decimal is equal to base 10. And then hexadecimal is equal to base 16. Okay. But what if you have a base 3? So we don't actually have a base 1. Well, you can have a base 1. However, we don't use that one anymore. So that's why the minimum one is a base 2. It's either 0 and 1. So what if we have, uh, let's say, 3 characters? So in here, we call that one base 3. Okay. Or not 3 characters. This one is 0 to 1. Let me just arrange this one properly. But what if you have 0 to 2? Okay. It's the best representation of this base 3 right here. So 0 to 2 characters, okay, is called base 3. And then 0 to 4 is called, let me just remove these characters right here. 0 to 4 is called base 3. Oops, my bad. This one is base 0, 1 to base 3. This one is base 4, 0 to 3. Okay. And then if you have 0 to 4, and this one is base 5. If this one has a 0 to 5, this one is base 6. 0 to 7, I mean 0 to 6 rather, it's now 7. And then 0 to, 0 to 7 is base 8. Huh? Ka I'm not confused. 0 to 2 is 3, 4, 5, 6, base 7. 0 to 7, yeah, that's correct. So 0 to 7 is now called the octal or a base 8. If you have 0 to 9, I mean 0 to 8, sorry for that. Okay, this one now is called the base 9. And then for the decimal, of course, this one is 0 to 9. Okay. And then for the hexadecimal, this one is of course 0 to 15. Okay. And then 11 is 0 to 10. Base 10, base 11. And then 0 to 11 is base 12. And so on and so forth. Okay. So let me just finish this one. 12, 13, 14, 15. 12, 13, 14, 15. And this one now is 12, 13, 14. So there you go. So we only have 4 proper namings We have the base 16, base 10, base 8, and then base 2. But the rest, we call them n base already. Okay, so those are 0 to 2, 0 to 3, and so on and so forth. Okay, so I hope you guys were able to get this one. So is it okay so far? Were you guys able to get the logic on, how to separate n base versus the one that has a proper namings, which is, those four? So how many percent so far that you guys were able to understand this called n base number system? So just let me know if you're confused. Okay. So aside from binary, hexadecimal, octal, and decimal, those are already called n base. So in here we have a base 3. Okay. So we call that one n base. So 12.2 3. So even though it's n base, so we still have the same process. Okay, there's no major changes. So in fact, there is no changes aside from the multiplier. So just arrange this one from top to bottom. So 1, 2, 2, and then our multiplier is 3. So times 3 times 3 times 3, and then this one is starting from the decimal. So we have -1, and then this one is 0, and then followed by 1. And then just do the math using your calculator. You will get 5.6666 base 10. Okay, so the same with letter P. So arrange this one from top to bottom, and then our multiplier is 5. And then starting from here, we have -1, and then 0, and then 1 and 2. And then just add everything. You will get 38.2 base 10. So, are we clear so far regarding with this one? Okay. So, in here, you don't actually need to remember, what base will it be coming from when it comes to converting it to decimal. Okay, so this one is just a multiplier when it comes to converting this one into a decimal. So you don't need this one is binary, so this is the process that I should follow. This is octal, so this is the process that I should follow. So you don't need to do that one because all in all they are just the same. Okay, they just differs with how many characters they have, what are the characters that they have, and then what is the multiplier that they have. Okay, and so on and so forth. Okay, so everything is pretty much the same. Okay, so more examples when it comes to NB. So we have base 9. Okay, so just arrange this one from top to bottom, 8, 7, 5, 4, 3. Starting from here is 0, incrementing. And then starting from here is -1, and then it's decrementing. Just add everything, you will get this one. So the same with this one, arrange this one from top to bottom. So remember our letters. So you still need to convert them. So A is 10, B is 11. Okay, and then our multiplier is 13. So -1, 0, 1, and then 2. Then just add everything, and then you will get this result right here. Okay, so are we good so far up to this point? So just verify this one later on, as long as you're getting the idea on or the process on how did we get those results. Then you're already good to go. Just verify this the results later on. Okay. Okay, so clear, or anyone who has a question so far? Hello, guys, still around? Okay, so are we good to this point? Okay, so just let me know if you guys need more examples. Okay, but that's pretty much it when it comes to converting n digits to decimal. So you can do anything, okay, as long as you know the process. Okay, it doesn't matter what base is that. So let's now move on to the by default numbers to decimals. All right, so supposedly this will be your seat break, but since we are in ODL, so I will not give this one as your seat break. So just do this one as your self-study exercise. Okay, so answer this one on a clean band paper if you want. So no need to pass this one anyway. But if you wanted to, let's say, practice and then let me verify whether your answers is correct or no. So just message me. So just take a screenshot of your solution course of this one, and then you can ask me if you did correct regarding with this exercise right here. Okay. Anyway, so a while ago you can convert binary, octal, hexadecimal, or n-base decimal. Well, of course, you can also do the reverse. Okay, wherein you can convert decimal into any base. Okay, so to do that one, we have this process right here. So decimal to integer, another base. So number one, repeatedly divide the given decimal number by the base where you want the decimal to be converted to until the quotient is 0. So for each division operation, tally the remainder. And then if the quotient is already 0, write all the tallied remainders by reading them in upward direction. Okay? So for you, again, for you to be able to appreciate this one a little bit more, let's have an actual example. Okay, so before we just keep on multiplying things, but in here, we now need to divide and divide and divide and divide until you will get an integer quotient of 0. Okay, so let's start with this one. So letter A, convert 13 base 10 to binary. So in here, our divisor is where you wanted to convert this decimal. So this decimal is being asked to convert to binary. Then binary now is our divisor. So binary is 2. Okay, so it has a base of 2. So just divide this 13 right here into 2. And then separate the results into two parts. So the first one is integer quotient. And then the second one is the remainder. Okay, so 13 divided by 2 is 6, remainder 1. Okay? And then after that, just get this one, 6, then put it right here, and then divide it by 2 again. So 6 divided by 2 is 3, remainder 0. Okay? And then just get this one again, this integer quotient right here. And then 3 divided by 2 is 1, remainder 1. Okay, so take note that you cannot put here, let's say 3 divided by 2. Well, the exact answer of this one is 1.5, right? But since we are talking about integer quotient, so it's integer, so whole number only, then you have to get the whole number result only, which is 1, and then put the remainder on this side right here. Okay, and then the last one, 1 divided by 2 is actually cannot be. Okay, or we could say that yeah, it's possible, but the result is 0.5. So that's the reason why integer quotient is already 0, and then the remainder is 1. Okay, or whatever is that last number right here. Okay, so as a result, the one that you're going to get as your final answer would be the remainder. So 1101. So starting from the bottom, it's 1101. So 1101 base 2. So from 13 base 10, it is now converted into a binary base 2. Okay, so I'll give you guys 30 seconds to 1 minute to analyze this one. So let me know once you have already got the idea or already understand this one. So just give me a thumbs up just to let me know that you're good. Okay, so good so far. There's 6, 7, 8. All right. So another one. So again, you will only stop once you reach a value of 0 in integer quotient. Okay, and then after that, whatever you have here in the remainder, then that is now your final answer. Okay, so yeah, that's pretty much it for this letter A. So let's have more example, letter B. So 37 based 10 to binary, so still a binary. So our divisor is still 2. So 37 divided by 2 is 18. Okay, remainder 1. 18 divided by 2 is 9, remainder 0. 9 divided by 2 is 4, remainder 1. 4 divided by 2 is 2, remainder 0. 2 divided by 2 is 1, remainder 0. 1 divided by 2 is cannot be. So just put here 0 now, and then whatever is your final number, just put it right here as your final remainder. And after that, you can now read this one from bottom to top. So 1, 0, 0, 1, 0, 1, base 2. Okay. So in your quiz, of course, we're going to have a quiz on module 4. In your quiz, you don't need to put the base anymore. Okay, so all you need to put is the answer that you were able to solve. So in here, just the put 100,101. No need to include the unit anymore. Okay, or the base. Okay, so again, just give me a thumbs up once you're done in analyzing and you were already able to understand this second example. Okay, good. Okay, great. Most of you were able to get it. Okay, next example. So we now have 2010 as a decimal, but in here it is now asking us to convert this one into a octal. So our divisor before is binary, I mean 2, but in here our divisor now is 8 since that's the number that we wanted this decimal to be converted to. So 2010 divided by 8, you'll get 251 point something. So since this is already a large number, so you have to use now your calculator. Okay. So 2010 divided by 8. So in my case, I will get 251.25. So just put here the 251, okay, on the integer quotient. And then the 0.25, just get that one. 0.25, multiply that one to our divisor. Okay, 0.25 times 8, then it will give us a remainder of 2. Okay, so that's how we've got the value of remainder. So 0.25 times 8. Okay, so were you guys able to get that one? The 251 and then the 2 on the remainder. Okay, well, if you want, you can do this one using the old way, like elementary days. It doesn't want to be deleted. Ah, sleeping tool pala to. Okay, like, what is that again? 251, 2010 divided by 8. 2010 divided by 8. So in here we have 816. So 2 minus 16. So it's 4. Bring down 1. 8, 16, 80, 42, 40. Uh, it's 5. Ano ba? Mali pala ginagawa ko. So it's 40. So 5 times 8 is 40. So minus 41 minus 40 is 1. So bring down 0. So 8 is 1. Minus 8. So 2. So whatever is the last one right here, that's now your remainder. Okay. So this is your integer quotient, and then this is your remainder part. Alright, so you can do this one if you want. Okay, well, if you don't want to write, then you can use your calculator instead. All right, so that's how we've got this 251 and then 2 right here. And then again, just get this 251 divided by 8. Okay, so in my case, I'll use my calculator since this one is a lot easier. 251 divided by 8. We've got here a result of 31.375. So 31 for the integer quotient. And then 0.375 times 8 will give us a result of 3. Okay, and so on and so forth. So 31 divided by 8 is 3, remainder 7. 3 divided by 8 is cannot be. So just put here 0, and then whatever is our last integer quotient, just put it here as your final remainder. Okay, then you can now get the final result on the remainder. So 3732 base 8. Okay, so I hope you guys were able to get this one. So if you have questions or clarification, so feel free to ask that one on the part 3. So goodbye for now since you don't have enough time anymore. So let's just meet again on the part 3.